Hello, my name is Benjamin. I am a mechanical engineering student, and for this lab we have to make a presentation of any of the main subjects that we covered in class. The subject that I chose was engines in thermodynamics. So I will talk about how steam engines work, how about the input temperature, and about the efficiency of an engine. Okay, to start off, in a steam engine, we would heat the steam by either using coal or oil. The input heat is used to heat the water, creating steam. Then an intake valve opens, allowing the steam to travel into the piston, pushing the piston upward, creating work. The intake valve closes and an exhaust valve opens, pushing the steam out of the piston into a condenser, creating a low pressure or a vacuum. The vacuum pulls the piston down to its original position. The steam at the lower temperature turns into water. Once that steam turns into water, then the cycle will repeat itself. We'll go back up, it will be heated into steam, steam into the piston, back into water, cycle all over again. And that is how a steam engine works. So next I will talk about input temperatures. Steam engines start with high temperature to low temperature. So the engine takes that high temperature and turns some of it into work, and some of that high temperature gets turned into exhaust. So our equation for our input temperature is QH is equal to W plus QL. QH, of course, is the input temperature. W is work, and QL is the exhaust. Okay, so now that we know the input temperature and the equation, we can start to figure out the efficiency. So we can figure out the efficiency of, like, let's say steam engines or internal combustion engines. So with the internal combustion engines, we must know that the greater the exhaust heat, the less efficient that engine is, meaning that engine would have to use double energy for the same amount of work. So that engine would not be very efficient. Okay, in order to calculate the efficiency of the engine, we would have to we would use the equation E is equal to work over the input temperature, or we can write it input temperature minus exhaust temperature over the input temperature. Okay, so with this equation, the closer we get to 1, the more efficient that that engine is. So if, for example, if we put our values into that equation and we come out with a value of, let's say, 0.7, it means our engine is very efficient. Now, if we put in our values and our value comes out to 0.2, then that engine is not very efficient, and like I said before, that engine would have to use double energy for the same amount of work. Also, just to finish off the video, I do want to note that efficient engines make for slow cars. That's it. Thank you.